So we've been talking about slope and linear equations, and then we started talking about functions and average rate of change and things like that. So let's say you have a function that looks something like that, and you're trying to figure out, like an average rate of change. Well, let's say that you're here at x, okay? And so this point right here is x, comma, f of x. But then you go a little bit further, maybe over to here, and so there's this distance that you've gone x plus some distance h. So that's this distance here is h. So you've moved over to another point. And then this point is x plus h, comma, f of x plus h. And so when you go to do the average rate of change, for the secant line, so the secant line's like right here, and you're trying to figure out that slope. Well, what it looks like then is you take f of x plus h, subtract f of x, just like we did with a slope formula, and then in the denominator you'd have x plus h minus x. You'd have this one minus this one. Okay, so in the numerator you have f of x plus h minus f of x, but then in the denominator that simplifies just to be h. And this is what we call the difference quotient. We've seen that before in another section. And then if you go on and you take calculus, what they're going to say is, well, what happens then if h is getting closer and closer to x, such that h becomes 0? Anyway, this is called the difference quotient. We did a difference quotient, and we're just saying that's also an average rate of change. Okay.